Today we're going to be talking about how to find the limit of a vector function, and in this particular problem we've been asked to find the limit as t approaches 0 of this vector function e to the negative 3t times I plus t squared divided by sine squared of t times j plus cosine of 2t times k. Now, finding the limit of the vector function in this form is not too difficult because to evaluate the limit as t goes to 0, all we need to evaluate are the coefficients on our I, j, and k components. So you'll notice that our coefficients are the parts of our components that involve t. We just need to evaluate the limit as t goes to 0 of each of those, and we can do that separately for each component. So here's what that's going to look like. We can say the limit as t goes to 0 of e to the negative 3t, and then just multiply this whole thing by I. Then we can add to that the limit as t goes to 0 of our coefficient here, t squared divided by sine squared of t, and multiply the whole thing by j. Then we add to that the limit as t approaches 0 of our coefficient cosine of 2t and multiply the whole thing by k. So you can see we can just take each limit individually. If we evaluate e to the negative 3t as t goes to 0, we get negative 3 times 0, which is 0. E to the 0 is just 1. So this whole thing, this whole limit as t goes to 0 of this function here, just becomes 1. So we have 1 times I, or just I, and it simplifies that easily. For this second term here, multiplied by j, if we try to take the limit as t goes to 0, we'll get 0 in our numerator. We'll also get 0 in our denominator because sine of 0 is 0. When we have 0 over 0, remember that's an indeterminate form, and we can use L'Hopital's rule to try to simplify it. So in order to use L'Hopital's rule, what we're going to do is say the limit as t goes to 0. We're going to take the derivative of our numerator. The derivative of t squared is 2t, and we're going to replace t squared with 2t. So in our numerator now we have 2t divided by, we're going to do the same thing in our denominator. We're going to take the derivative of sine squared of t and replace sine squared of t with its derivative. So how do we take the derivative of sine squared of t? Well, first we want to remember that we can write sine squared of t in the form sine of t quantity squared. This is the same thing as sine squared of t. So now we just need to use chain rule to take the derivative. Essentially here we're going to use power rule first. We're going to bring this exponent out in front and get 2 sine of t, subtract 1 from the exponent, 2 minus 1 is just 1. So we're left with 2 times sine of t, ignoring this inside function completely, but now we have to multiply by the derivative of the inside function. The derivative of sine of t is cosine of t, so we multiply by cosine of t, and this is our derivative function. So we get 2 sine t cosine t, and we multiply that by j. Now here for the coefficient on k, cosine of 2 times 0, or cosine of 0, is equal to 1, because cosine of 0 is 1. So this whole thing, limit as t goes to 0 of cosine of 2t, just becomes 1. We get 1k, or just k. So I and k simplified really easily. We just need to go back to our j component here. Again, if we try to evaluate the limit as t goes to 0, we get 0 in our numerator, and we get 0 in our denominator because sine of 0 is 0. So again, we have to apply L'Hopital's rule, and we'll get limit as t goes to 0, again taking the derivative of the numerator and denominator and replacing our numerator and denominator with their derivatives. In our numerator, we'll get 2 because the derivative of 2t is just 2. In our denominator, we'll need to use product rule. So if we have 2 sine t cosine t, and we treat these as two separate functions. Let's pretend 2 sine t is one function and cosine t is our second function. Using product rule to take this derivative, we want to take the derivative of our first function. So the derivative of 2 sine t is 2 cosine t. We multiply that by our second function as it is, so multiply by cosine t. Then add to that, here this time we flip roles, we leave the 2 sine t alone, and then we take the derivative of cosine t. Well, the derivative of cosine t is negative sine of t, like this. When we simplify, we'll get 2 cosine squared t minus 2 sine squared t. Now, if we plug this back in here, we get 2 cosine squared of t minus 2 sine squared of t. We multiply that by j, and then we add here k. Now, as you can see, we can get our 2's to cancel because we've got a 2 on each term. Now we just have to evaluate the limit as t goes to 0. Well, in this case, our 2's canceled. Remember, we can think of each of these now as 1, 1, and 1. So we've got a 1 in our numerator, so we're going to get 1 in the numerator. In the denominator here, when we plug in 0 for cosine squared of 0, cosine of 0 is just 1. When we square it, we get 1. Sine of 0 is 0. When we square that, we get 0. So our denominator is just 1 minus 0 multiplied by j, and then we add k to it. And when we simplify here, you can see we're going to get 1 over 1, or just 1. So our final answer is going to be I plus j plus k, and that's how you find the limit of the vector function.